Welcome to FMSP Online Revision. This session is for OCR FP2 and the topic is hyperbolic functions. So we'll start by looking at the specification for hyperbolic functions, and when we'll be working through 3 exam questions and hopefully try and help you get as many marks as possible when it comes to the exam. So starting with the specifications. So candidates should be able to recall the definitions of 6 hyperbolic functions in terms of exponentials and sketch the graphs of simple hyperbolic functions. So I have just put in here the definitions for sine, cosh and than, and underneath their graphs, but of course you actually need to be able to work with coshec, shec and coth as well. So make sure you know the graphs and that you're able to produce those in the exam. And then in part B, you've got to be able to derive and use identities such as cosh squared minus sine squared is equal to 1 and sine 2x is equal to 2 sine x cosh x. So identities similar really to those that you've done in A2 core for trigonometry. And in part C, you've got to use the notations sine to the minus 1x, cosh to the minus 1x, than to the minus 1x to denote the principal values of the inverse hyperbolic functions and derive and use expressions in terms of logarithms for these. So bear in mind that sine is a one-to-one function, so therefore we don't need to restrict the domain. So we can define the inverse for all values. But when it comes to cosh, then it is a many-to-one function, so we restrict the domain to x is greater than or equal to 0 when we're finding the inverse of cosh. And then than again is one-to-one, so we are able to find its inverse and we don't have to restrict the domain. In terms of the logs, then remember, since sines and coshes are defined in terms of exponentials, then it won't be any surprise that their inverses are defined in terms of logs. And those are you will be able to get from your formula book, although notice it does say you need to be able to derive them. So we'll move on now and look at some questions. The first question that I'm looking at really is and in this first part is bookwork really. You're asked to prove the identity cosh squared minus sine squared is equal to 1, and having done that, to deduce that 1 minus than squared is equal to shec squared. And then in part 2 you're asked to solve the equation 2 tan squared minus sec squared equals 1, giving your answer in logarithmic form, and hopefully you realise that once you've done part 1 then you're going to be using this identity to substitute it in here and solve the equation. So I have put the method for proving the identity in this little red box. So we substitute in for cosh and sine and square them. So squaring out the brackets we get this result. And then if we're collecting all the like terms, then hopefully you can see what happens is that the e to the 2x in each case is going to disappear. So this one and this one will cancel out, as will the e to the minus 2x and the e to the minus 2x here. And then all we're left with is the 2 plus 2, which is 4, so a quarter of that is 1. So just make sure that you can go through and prove that identity, and then having done that, then we divide both sides by cosh squared, so we'll get 1 minus sine squared over cosh squared, which is than squared, and 1 over cosh squared, which is sec squared. So Bailey, you get 1 mark here for substituting in the cosh and sine. You get a method mark for multiplying out the brackets, and then an accuracy mark for collecting all the terms and showing that it's equal to 1. And then you get 1 mark just for dividing through by cosh squared to get this result. So 4 marks for that first part. If we look at the second part now, as I say, over here I have just put the result that we got from part 1, and we're going to use it. 1 minus tan squared is equal to chef squared. And then the other is we're going to need to use that at the end because it says to give our answer in logarithmic form. And of course this result, I've put it in green because it comes from your formula book. So it's not something that you actually need to learn. So if we just start by doing this then. So 2 tan squared x minus sec x equals 1. So we're going to replace tan by 1 minus sec squared x, and then it's really just a matter of bringing all the terms over to this side and writing it as a quadratic in sec, and we get that. Now you would always hope that at this stage it will factorise. If it doesn't, it's worth just going back and checking that you haven't made any sort of silly error. So there has to be a 1 each, and it's just a matter now of making sure we have a plus sec squared, so that is going to be that. So sec x is equal to a half, or sec x is equal to minus 1. Now hopefully we know that sec is 1 over cosh. Cosh is always positive, can't be negative, so that's not defined. So we end up just with this answer. So cosh x is equal to 2, and we need x, so x will be cosh to the minus 1 of 2, and this is where we now use this logarithmic expression for the inverse of cosh. So substituting in 2, we'll get log of 2 plus root 3. So hopefully that is all right. In terms of marks, 4 marks for the question in total. You got 1 mark for substituting in the fact that sec squared is 1 minus tan squared and rearranging it as a quadratic. You got 1 mark here for getting these results and seeing that sec x equals minus 1 isn't possible. And then you got an accuracy mark for cosh x equals 2 and another for x equals log of 2 plus root 3. So we'll look at another question. This is another question which involves some bookwork, and I just want to sort of make sure you realise that any of these things can be asked in an exam. So given that y equals tan to the minus 1 of x, we've got to prove that y equals a half of log 1 plus x over 1 minus x. So we'll use the exponential expression for tan, and we'll take this one, so I've multiplied top and bottom line here by e to the y. So this is the form that we'll want, and then it's really just a matter of rearranging to make 2y, e to the 2y, the subject. So if we do that, we will end up with x upon e to the 2y plus 1 equals e to the 2y minus 1. Collecting all the terms involving e to the 2y, we'll get that, and then just dividing through by x to the minus 1 and tidying it up in terms of signs. So I'll multiply everything by negative 1. We get that, and then of course it's just a matter of taking logs now. And so we end up with the result y equals a half of log of 1 plus x over 1 minus x. Three marks for that question. So there was 1 mark for using this form for x, e to the 2y minus 1 over e to the 2y plus 1. There was a method mark for rearranging it to make e to the 2y the subject of the formula, and then an accuracy mark for taking logs of both sides and getting the right answer. So as I say, it is bookwork, but just a reminder that you do need to be able to work through that. And the last question that we're going to look at from January 2011. So part 1, using the definitions of hyperbolic functions in terms of exponentials to prove that 8 sine to the power of 4x is equivalent to cos 4x minus 4 cos 2x plus 3. And then in part 2, solve the equation cos 4x minus 3 cos 2x plus 1 equals 0, giving your answer in logarithmic form. So in part 2, we're going to do it by using the answer to part 1. There will often be different ways in which you can solve these, so as long as you have a correct method, but generally speaking, when you have them numbered like this, the chances are you're going to be using the answer to part 1 when you come to part 2. So let's have a look then at part 1. So 8 sine to the power of 4 of x is equivalent to, now using the exponential form, so we know that it's a half of e to the x minus e to the minus x to the power of 4. And just simplifying that, a half to the power of 4 is a 16th, so 8/16, so that's a half of, and now we need e to the x minus e to the minus x to the power of 4. And when I do this, I'm going to just use Pascal's triangle. So the coefficients of Pascal's triangle, 1, 4, 6, 4, 1. So we'll have e to the 4x, 1e to the 4x. We'll then have 4 lots of e to the 3x, but that will be multiplied by minus e to the minus x to the power of 1. Then we'll have 6 lots of e to the 2x times minus e to the minus x all squared. And then we'll have 4 lots of e to the x times e to the minus e to the minus x, I should say, all cubed. And then we'll have 1 lot of e to the minus 4x. All of that is multiplied by this half. So if we simplify that now, then it is just a matter of seeing that what you've got is you've an e to the 4x here and an e to the minus 4x. So we'll bring those two together. We then have a minus, this is going to be minus 4 e to the 2x, and this is also going to be a minus 4 e to the 2x. So if I take the 4 outside and the minus outside the brackets, then we've got an e to the 2x and an e to the minus 2x. And then here you'll notice that e to the 2x and e to the minus 2x, that's just going to give us a plus 6 because the minus sign is squared. And now, of course, we can hopefully see that that is a half of e to the 4x plus e to the minus 4x. And then we're going to have a half times 4, so that's minus 4 lots of a half of e to the 2x plus e to the minus 2x plus 3. And that, of course, is now cos 4x minus 4 cos 2x plus 3. So you do have the answer, and you have to show it to prove it. So just be very careful that you do show all the working, but on the other hand, you do know what you're aiming at. So in terms of the marks, so 1 mark up here for just writing this down here, substituting in for shine and simplifying it to a half of e to the x minus e to the minus x to the power of 4. You then got a method mark when you came down, when you got as far as here, bringing these terms together, and then an accuracy mark at this stage where you've multiplied everything through by a half, and then another mark for writing it then in terms of cosh 4x and cosh 2x. So that is part 1, and we're now going to have a look at part 2, where it says solve the equation cosh 4x minus 3 cosh 2x plus 1 equals 0, giving your answer in logarithmic form. So as I say, there are different ways in which you're going to do it, but I'm going to make use of this. So I'm going to rearrange that to make cosh 4x the subject. So up here, if I write that, I know that cosh 4x, which I need here to substitute in cosh 4x, is equal to 8 shine to the power of 4x plus 4 cosh 2x minus 3. So I've just rearranged that answer for part 1. The other thing that it's probably just worth reminding you at this stage is the double cosh 2x formula. So cosh 2x is equal to 1 plus 2 shine squared x. So we're going to need to use those to substitute in. So starting with cosh 4x minus 3 cosh 2x plus 1 equals 0. I'm now going to substitute everything in. So I'm going to have 8 shine to the power of 4x plus 4 cosh 2x minus 3, so that's just from what we did above, and then I'm going to put in, I'll leave that for the moment, but I will put that in at the next line. So we've got minus 3 cosh 2x plus 1 equals 0. And now what I'm going to do is substitute in here and bring the minus 3 and the plus 1 together. So we'll get 8 shine of 4x. We've got 4 cosh 2x there and 3 cosh 2x there, so that's 1 cosh 2x. Maybe just do this in 2 lines. Minus 2 equals 0. And now we'll substitute in cosh 2x is 1 plus 2 shine squared. And we have a minus 2 here and a plus 1 here, so that's going to be minus 1. Now again, at this stage, one would hope that it will factorise. And luckily this one does, so it'll be 4 shine to the 4th shine squared x minus 1 upon 2 shine squared x plus 1. Just check your factors there. We're okay. So that tells us that shine squared x is equal to a quarter, or shine squared x is equal to minus a half. Now that one, of course, is not possible. And so we know that shine x is equal to plus or minus a half. Now again, just as we did in the previous question, we need to go to our formula books to find the inverse, because of course we're now going to say that x is equal to the inverse sign of plus or minus a half. And that means that x is equal to the log of, that's an n, log of plus or minus a half plus a half root 5. So I'll let you check, but that's just substituting in. So we've looked up in our formula books, sign to the minus 1 of x is log of x plus the square root of x squared plus 1. And then we substitute that in, and that's the same as plus or minus log of a half plus a half root 5. So there's quite a lot of sort of manipulation there that you need to be careful with. So in terms of marks, so you got a method mark here for substituting in the result from part 1, that cosh 4x was 8 sine to the power 4x plus 4 cosh 2x minus 3. You got an accuracy mark for getting the quadratic, and a method mark for factorising, and then you got 2 marks for rearranging, finding the sign of x to be plus or minus a half, and using your formula books to substitute correctly into the logarithmic form. So 5 marks in total. So I'm going to end this session here and just remind you that, as always, the best way of revising your maths is to do lots of questions.